Hello everyone, welcome back to Chemical Engineering and Aspen channel. In our today's video, we will use Aspen Exchanger Design and Rating software to rate or to check the falling film evaporator. Previously, we have performed the design related activities, but now today we will do the rating part in Aspen Exchanger Design and Rating. But before going to the main part of the designing or the rating, we will first have a look at the basic concepts of the falling film evaporator, that it is a type of industrial heat exchanger which uses a thin film of liquid flowing down heated tubes to concentrate solution, making it ideal for heat sensitive products. Liquid is fed in from the top and distributed evenly over a bundle of vertical tubes where it flows down, forming a film. As the liquid descends, heat from a steam jacket evaporates the solvent, and the vapor and concentrated liquid are separated at the bottom of the unit. This design provides high heat transfer efficiency, short residence time, minimizing product degradation. So this is the overall introduction of the falling film evaporator. If we talk about or divide it into the different parts, first one is the liquid distribution, that the solution which needs to be concentrated is introduced from the top of the evaporator and distributed evenly over the heating tubes. Second is the film formation, that as the liquid flows down the inside walls of the heated tubes, it forms a thin film. Then evaporation, that steam or an other heating medium on the outside of the tube transfer heat to the liquid film, causing the solvent to evaporate, followed by the separation, that the generated vapor rises to the vapor head while the remaining concentrated liquid flows to the bottom where it is collected. And finally, once we talk about the efficiency, the thin film and short contact time prevent the liquid from being exposed to high heat for prolonged periods, protecting the heat sensitive products. This is the overall introduction or a brief overview of the falling film evaporator, which you need to understand before going to perform the simulation or before going to perform the design or rating task using the suitable software. So now we will go to the Aspen Exchanger Design and Rating, and we will rate the falling film evaporator using it. So this is the overview of the falling film evaporator, which we have to rate. If we click on it, evaluate how over or under surface the defined exchanger geometry is for a process requirement. Calculation mode is rating. We have selected A, E, L type. A is for channel removable cover, E is for one pass shell, and L is for removable channel with flat cover. The tube option is new. Location of hot fluid is shell side. The tube OD and pitch are 2 and 2.5 inches respectively. The tube pattern is 60-degree rotated. Tubes are in baffle window. Baffle type is single segmental. Shell ID OD are 27, 28 inches respectively. The tube length is 13 feet. The baffle spacing center to center is 10 inches. The number of baffles are 12. The number of tube passes 1. Shell in series 1. Shell in parallel 1. Then going to the process, the mass flow rate of cold side is 13,228 pound per hour. The inlet pressure of the hot side is 11.38, while that of the cold side is 6.66. The outlet pressure is 10.88 and 6.46 for hot and cold streams respectively. The inlet temperature of the cold side is 176 degrees centigrade. The inlet vapor mass fraction for hot and cold side are 1 and 0 respectively, while for outlet are 0 and zero point 0.2 respectively. Then the allowable pressure drop is 0.5 and 0.2 psi for hot and cold sides, and the fouling resistance value is 0.001 square feet per hour per degree Fahrenheit per BTU for both hot and cold sides. Then if we define, go to the problem definition. In application options, equation of hot fluid is shell side. Select geometry on the basis it is US. Application for hot side is condensation, because we say it is condensing, and how it is transformed into a cold side, because the model type selected is shell and tube. That in application we will select vaporization, and then here we will select the falling film evaporator. So this is how this model is converted into the falling film evaporator. Then process data as it has been provided or we have already studied about it. In property data, the hot stream is water, which we have defined using BJAG, and the property method is ideal. In cold stream, it is user specified, and in user specified, we have specified the values. Obviously, you can pause this video here and you can just draw these or you can just write these in your Aspen about the temperature, density, specific heat, viscosity, molecular weight, enthalpy, and so on. So all these properties are provided here. Then going to the exchanger geometry, the geometry is already well defined previously as I have informed you. Then the shell heads, these are also defined as well. No change in cover, tube sheet or flanges, these are by default. Then in tube side, we have defined that 13-foot tube length, tube type is plain, and accordingly all the information in the tube material is SS304. Then in baffle supports, again single segmental, yes, and baffle cut is 40%. Baffle spacing center to center is 10 inches. Number of baffles are 12. There is no other input in tube supports, variable baffle patches, or so on. Going to the bundle layout, again the information which is provided to you is shown here. Then in nozzles, we have specified inlet nozzle for shell side as SB 6 inch, for outlet is SB 4 inch. Then for tube side, 4 inch for inlet and 8 inch for outlet. This is the input from us. Rest of the things will remain the same. Going to the construction options, material of construction is for tube material is SS304, while the shell side or the other material is carbon steel. In design specification, we have updated the TIPA class as R, refinery surface, service. Going to the program options, in design options, we have specified shells and side nozzle location options, same side, and the rest of the things are by default. Then in thermal analysis, we have not provided any value. These are also by default. In method and calculation, and again, all rest of the things are the same. So this is the overall overview of how we have input all the values in Aspen Exchanger Design and Rating. Now we will click on the run button to get our required results, and you can see there is no warning in the system. The process converged after 22 iterations. And if we go to the results in optimization path, this is the information about the design, recap of designs. This is the information of the design which is available to us. Then in TEMA sheet, the overall information is provided to us. The exchanger type or the exchanger sketch is also provided. Each information about the heat exchange, transfer rate, dirty, clean, factors, or IDOD, all the information is provided in this TEMA sheet. And in overall summary, you can see about all the performance of shell side and tube side and all the corresponding properties, whether it is density, viscosity, specific heat, thermal conductivity, or so on. Every information is provided here in this result summary. In performance, in heat transfer, in pressure drop, flow analysis, vibration analysis, method of convergence, every information is given in this part in the summary as well, which you can obviously go through it one by one in detail. In exchanger geometry, the information is given going to the setting plan. This is the overall setting plan of this heat exchanger, and you can see the overall dimension is given to us, the pulling length, all the values, corresponding values are provided here. Design pressure, design temperature, corrosion allowance, number of passes, internal volume, every information about it is given to us. And accordingly, the tube sheet layout is provided. In cost weights, the total cost of this one shell is provided as $35845, while for all shell, because it is just one shell, so the one shell and the all shell cost will remain the same. So it is $35845. The labor cost, tube material cost, every cost is calculated over here. Then analysis along shell side, the complete analysis of the properties is provided to us. The interval analysis, the physical property analysis, and same across the tube side as well. So this is the overall information or overall procedure of how to rate a falling film evaporator using Aspen Exchanger Design and Rating. I hope you have understood all the aspects of this lecture. If you have any queries, feedback, suggestion, Please provide it in the comment box and I would be happy to answer. So that's it from today's lecture. Thank you so much. Please do watch, like, share the video and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.